right, section 38 is the day you've been waiting for. It's very exciting. It's when we relate integration, the thing with the elongated s, to antiderivatives. So it makes things like the, remember how we did the infinite sums with the sigma? It makes it super fast. You can do it in like 10 seconds instead of like 30 minutes. So it's very exciting to learn this. Okay, so it says, suppose you know the velocity of an object at a certain time, but you want to know its position. Okay, or maybe you know the rate at which a population is increasing, but you want to know what the population was at a specific point in time. In order to do this, you need the opposite of derivatives, which are called antiderivatives. So I know that we've talked about that before. We might also call it indefinite integration. We usually denote the antiderivative of a function f of x with the capital letter F. If we want to notate that we're finding the antiderivative, we use an integration sign, which I showed you before, looks like an elongated S. You'll often hear the term integrate instead of find the antiderivative. So you should know whenever you see integrate or find the antiderivative or something like that, it means exactly the same thing. So it says find the indefinite integrals. Basically, this means that we have no limits of integration. We don't have an A to B. Okay, that's what limits of integration are. When we do this, that means that you will need a plus C at the end. So you could always have some kind of constant that you take the derivative of and it goes away. Okay, so this first one. So if I have the integral of 1 over x cubed dx, remember we've talked before about how that's x to the negative 3 dx. So what we're saying is, what do I take the derivative of in order to get x to the negative, oops, I said negative 1/3, x to the negative 3, right? So what I would have to do is I would have to add 1 to the power, and then I do 1 over that new power. Okay, so we talked about this last semester. So we could write it like that, or we could have negative 1 over 2x squared, and we need that plus c, just so if we were taking the derivative to check, we could have had any number there. We could have had a 5 or a pi or a 7 or whatever. All right, so this one I rewrite, so I write 2 sine of x plus 3x to the 1/2 dx. So we end up getting 2. If I want to take the derivative of something and get cosine, or get sine, I'm going to need some form of cosine. But cosine's derivative is negative sine. It actually needs to be negative cosine to get sine out. And I have plus 3. I'm going to have x to the add 1 to the power, so I get 3 over 2. But I still need a 1 over 3 over 2 out front, which is 2/3, plus c. So I get negative 2 cosine of x plus 2 x to the 3 over 2 plus c. And you can always take the derivative of this to see if you get the original. Okay. So that was kind of a review. We've talked about that. We talked about the power rule. If I have the integral of x to the n, it ends up being x to the n plus 1 with a 1 over n plus 1 out front. Okay? But we do make the stipulation that n cannot be negative 1. In other words, we don't know at this point how to find the derivative of 1 over x. If I actually have, or not derivative, antiderivative of 1 over x. If I have that, it's actually equal to the natural log of the absolute value of x, plus c, of course. And we'll talk about that later on. But that's one thing that will not work. And if you think about it, as you try to add 1 to the power, you're like, oh, I have x to the 0, and then I have 1 over 0, right? That's wrong. You can't have the 1 over 0 part. So that should kind of be your red flag as you're doing that it's a natural log answer. All right, and we did a little bit of this last time, but we're going to do a little bit more. So it says, not last time, but last semester. So if I have f prime of x equals x to the 3 over 2 and f of 1 equals 2, this allows us to solve for our c. Okay, so we call this an initial condition. All right, so if I take the antiderivative, right, I had f prime, I want to find f of x. I add 1 to the power. I do 1 over the new power, so I flip it and it becomes 2/5 plus c. And this is saying that when we plug in 1 for x, we get a y value of 2. Okay, that's what allows us to find the c. So we have 2 equals 2/5 plus c. So I'm going to have 10 over 5 is the 2 minus 2 over 5 equals c, so I get 8/5 equals c. So our last step is to always write that function So I still have 2/5 x to the 5 over 2. But now I found my c, and it's 8/5. Okay, so hopefully this is all review. You're feeling good about this so far. So the next one I have f double prime. So I'm going to go all the way to f prime. So I'm going to have f prime of x is going to be x to the 4th. I would have a 1 over 4, but times 20 is going to be 5. I'm going to have x cubed. I'm going to have a 1 over 3, but times 12 is 4. 4x plus c. And I'm given that f of 0 equals 8. Well, that's not helping us because right now I have f prime. Okay, so I continue. So it's a little bit tricky. We haven't done one like this before. So now I do f of x. So I'm going to have x to the 5th. I would have a 1/5, but I already have a 5. So we're good. X to the 4th. I would have a 1/4, but I have a 4. So again, it cancels. I have x squared. I need a 2 to make that 4, right? 4 times 1/2 is 2. And then I have to integrate the c. So c is a number, so it's just going to be cx. But then I'm still going to have another variable. So we can't put c again because we've already used c. So that's when I do d, where a lot of people will do c1 and c2 with subscripts. Okay, and this ends up being a system of equations because I was given two f values. I was given f of 0 is 8 and f of 1 is equal to 5. So f of 0 gives me 8. So that means when I plug in 0, I get 0, 0, 0, 0 plus d. So right away I get d. So we're good. And I know when I plug in f of 1, I'm going to get 5. So I have 1 plus 1 plus 2 plus c times 1 plus 8 has to be 5. And that's going to allow me to solve for c. So 1 plus 1 plus 2 plus 8 is going to be 12. So I have c plus 12 equals 5. So c equals -7. So my final function is going to be f of x equals x to the 5th plus x to the 4th plus 2x squared minus 7x plus 8. So that one wasn't too bad because we were given f of 0, which is always nice to have f of 0. But if I had said like f of 2 equals 8, then it gets pretty tricky. That's when you have to use substitution or elimination. Okay, so you don't see those too often, but you definitely could. All right, number 4. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Use the fact that gravity, or acceleration, so my a of t, is -32 feet per second squared. Okay, so if my acceleration is -32, that means my velocity is going to be the antiderivative of that. So it's going to be -32t plus some constant. So we were told that our initial velocity, v of 0, right, velocity at time 0 is 64. So that's going to be -32 times 0 plus c. So as you can see, the c value is always your initial velocity. Okay, so I'm going to have v of t equals -32t plus 64. Likewise, when I take the antiderivative of this, I get my position function, which we notate with s of t. So when I take the antiderivative of that, I get -16t squared plus 64t plus some constant, d. And that constant ends up being the initial height. So it said at initial height of 80 feet, well, that means s of 0 is 80. So it's 0 plus d. So you see how d ends up being 80. So our function, s of t, is our position function, and it's -16t squared plus 64t plus 80. Okay, so in a lot of like Algebra 2 books or pre-calc books, you often saw the formula -16t squared plus v sub o t plus h sub o. That's where that's coming from. Okay, so that's a common formula, and it comes from calculus. So part B says, well, when does the ball hit the ground? So if the ball is going to hit the ground, that means our height or our position is equal to 0. So we're going to have s is equal to 0. So 0 equals -16t squared plus 64t plus 80. And we can try to factor. 16 does go into each one. And I believe it does factor into t minus 5 and t plus 1. So I get 5 and -1. So the -1 is basically saying if we weren't at a height of 80 feet, then going backwards, it took 1 second to go back to the ground level, right? But we're throwing it from the top here at 80 feet. So it's taking 5 seconds from here to hit the ground again. So 5 seconds is our answer. All right, so this is kind of where it gets a little bit tricky, and a lot of people have trouble with this at first. Sometimes it's really obvious when you look at them, and sometimes it's not. Okay, so we're going to learn some ways to kind of identify when we see things like this. Okay, so the only thing we know right now is the power rule, and we know how to integrate sine and cosine, right? So we're going to have to use the power rule on these. We don't have any fancy tricks, kind of like the quotient rule, product rule for integration. We haven't learned anything like that. Okay, so we have to try to rewrite it into powers of x. So that's what I'm going to do here. So I'm going to have x over the square root of x plus 1 over the square root of x dx, which this was x to the 1, and this one was x to the 1/2. So if I have x to the 1 over x to the 1/2, when I subtract the powers, I get x to the 1/2, right? The reason that's happening is because x is really the square root of x, right? And we cancel. So I get x to the 1/2, and then I have plus x to the negative 1/2 dx. Now I'm ready to integrate. So I've gotten it so that it's all just powers of x. So if I add 1 to the power, I get x to the 3 over 2, and I do a 2/3 out front. Add 1 to the power, I get 1/2. 1 over 1/2 is 2 out front, plus c. Okay, so again, it's what we call an indefinite integral. There's no numbers that we're going to plug in. We're just going to have a c on the end. All right, same thing for this. The x squared can go into both pieces here. And I have x to the 5th over 5. Well, that's actually 1/5 x to the 5th, right? Does it make sense? 1/5 times x to the 5th is really x to the 5th over 5, right? So I can break it apart so I can see the number times the x to a power. So then I have minus, and that minus is out front of all of that, so I'm going to kind of think about parentheses there. So I'm going to have minus 4x squared, x to the 4th over x squared, and then minus 3x. So I've rewrote it, so I have an easier thing to integrate. Okay, I've rewritten it. All right, so here we go. So I'm going to have x to the 6th. I would have a 1/6 out front, but I already have a 1/5, so I'm going to leave it separate for now. And I have x cubed. I'm going to have a 1/3 out front, but I already have a 4. I have x squared. I would have a 1/2 out front, but I already have a 3. And then plus c. So my answer is 1 over 30 x to the 6th minus 4 over 3 x cubed minus 3 over 2 x squared plus c. All right, so something like this, sines and cosines. So we can't just integrate the numerator and the denominator. A lot of you guys try. You can't do that. Not allowed. Okay, we have to think about how to rewrite this. Okay, and sometimes it's a little bit tricky. Okay, so what I'm going to do is I'm going to think about sine over cosine times 1 over cosine. I'm going to try to break it apart into individual sines and cosines. Because I know that sine over cosine is tangent. And I know that 1 over cosine is secant. So now that I've done that, I see that I have secant x tangent x, which we didn't do those derivative drills for nothing, right? So when I see secant x tangent x, it is the derivative of something. Okay, it's the derivative of secant. Okay, so that's why you really have to have those down. So same idea for this one. Now, I can't break it apart. I can't put like, you know, over sine because I have a 1 minus sine squared. Okay, so it's not going to work. But I can notice that 1 minus sine squared is something that you should definitely know from pre-calc. In pre-calc, you learned that sine squared x plus cosine squared x is equal to 1. Okay, so hopefully all of you know that. That's called the Pythagorean identity. That is a very, very important identity in both pre-calculus and calculus. So if I have 1 minus sine squared, right, if I subtract it over there to the other side of the equation, right? It's all equal to cosine squared. So this is kind of where those identities in pre-calc come into play. You can rewrite things. You can say, oh, well, this is the same as cosine squared on the bottom. And then cosine squared over cosine squared is just 1. So if I'm integrating 1, then my answer is x. So x plus c. All right, and this one involves several powers. So this is going to be x to the 5/3 all over. Oh, kind of tricky because the 4 is under the square root too. So it's going to be 4x to the 8th. So when I take the square root of the bottom, I get 2x to the 4th dx. That number on front is on the top is 1. So if I think about breaking it apart into a number and a power of x, I have a 1/2. And I have x to the 5 over 3 over x to the 4th. So when I subtract 5 over 3 minus 4, it's really 5 over 3 minus 12 over 3. So I get x to the negative 7 over 3. Okay, so kind of messy. So now I'm ready to integrate. So if I'm integrating, I'm going to add 1 to the power. So negative 7 over 3 plus 3 over 3 is going to be negative 4 over 3. I put the new power, its reciprocal out front, so I have negative 3/4. But I still have a 1/2 and a plus c. So your answer should be negative 3 over 8, x to the negative 4/3 plus c. Okay, so we're getting a little bit harder. And then number 6, again, recognize that you have sine squared on the bottom. You don't want to write it as like 1 minus cosine squared using the Pythagorean identity because we don't want like a binomial on the bottom. We already have a monomial. That's good. But we can break it apart into fractions. So I'm going to think of it as cosine over sine and 1 over sine. And see if that gets me anywhere. So see how that bottom is still sine squared. You can think of it as 4 over 1 if you like. Okay, so when I do that, I have 4. Cosine over sine is cotangent. 1 over sine is cosecant. So we're kind of close. The 4 I can just pull to the front. And then I have cotangent x, cosecant x. Well, we've done something before where we take in the derivative and we get a negative. So think about this. If I had negative cosecant x, cotangent x, okay, you guys would know right away what that is. Negative cosecant x, cotangent x. That is the derivative of negative cosecant, or of cosecant, sorry. So don't worry about those negatives. If you didn't know to like draw those in, it's fine. Just know that this is going to be negative cosecant x when you take the antiderivative. So your answer is negative 4 cosecant x plus c. And you can always check. Remember, if you take the derivative, you can check. Its derivative is going to be negative 4 negative cosecant x cotangent x, right? And then negative 4 times that negative thing becomes positive 4. So we're good in the end. Okay, so you can always take the derivative to check. All right, so the last little bit we're going to talk about is definite integrals. So definite integrals have the elongated s, but they have numbers on them. Okay, and these numbers are called limits of integration. So what it ends up being is the antiderivative of b minus the antiderivative evaluated at a. Okay, so if I see the integral from 1 to 3 of 6x squared dx, okay, what I'm going to do is I'm going to find the antiderivative of this part, just like I did with the definite integration, or the indefinite integration. So I'm going to have x cubed of a 1/3, but I have the 6. Okay, so it ends up being 2x cubed. But I still have these numbers. I can't do a plus c in this case because I have numbers that I'm plugging in. So what I do is I put a little straight line, which indicates that I've taken the antiderivative already. So we always do a straight line after we take the antiderivative. And then we're going to plug in the 3 to our answer. And then we're going to plug in the 1 to our answer. We're going to find both of them, and we're going to subtract them. So I'm going to have 2 times 3 cubed. And then I'm going to have 2 times 1 cubed. And then I'm going to subtract those two answers. So I'm going to get 2 times 27 minus 2 times 1. So let's see, 54 minus 2. So our answer is 52. Okay. So this is called a definite integral. Definite means that we have a definite answer in the end. We don't have like that plus c, an indefinite answer, right? We don't have something where we don't know what the c is. Okay, we have found it. Okay, and really, if you had done it the long way and you'd written a c, right? Let's say you had, at this step right here, you would put a plus c in. It would still be the same thing because both of them would have a plus c, and the c is the same. Oops, plus c. So when you subtract them, right, you'd still have your, let's see, 54 plus c minus 2 minus c, and those c's would end up going away. Okay, so you can put the c in if you want, but it's kind of just extra. Like, we don't want to do that. Okay, it just takes too much time. All right, so this next one, so I have the integral of sine of x dx. So if I'm taking the antiderivative of sine, I get negative cosine, right? The derivative of sine is cosine, so the antiderivative is negative. That's, I always just remember, I find its derivative and add a negative for all of these. All right, so I'm going to have negative cosine of pi minus negative cosine of 0. So we'll really do plus cosine of 0. And then I know what those are. So in the unit circle, if I have cosine of pi is -1, so I have negative, negative 1. And cosine of 0 is 1. So I have 1 plus 1, which is 2. And then same idea on this one, so I'm going to do the antiderivative. So I'm going to get 9x minus 1/3 x cubed. And I put that little line that indicates that I've taken the antiderivative. Usually if there's multiple things, I put parentheses there too. And I plug in 3. So I get 9 times 3 is 27 minus 1/3 of 27. And then minus the other one, right? So when I plug in 1, I get 9 minus 1/3 times 1. So I have 27 minus 9, and then minus 9 minus 1/3. So let's see, I have 18 minus 9 minus 1/3. So 8 2/3, but what, let's see, so it'd be 27 minus 1, so 26 over 3. So what is this, 54? Yeah, 54 over 3 minus 26 over 3. So 28 over 3. Yeah, my mental math is struggling right now. So 28 over 3 is our answer. All right, so as you can see, if you're finding the definite integral, that's all we're doing. So when I put you through that pain of doing, you know, the sigma notation, like when you had something, I'm trying to think back to our last chapter. Yeah, so like on, I don't know, page 129, you guys have a picture in your notes of x cubed. And we were finding the integral from 0 to 1, or we're finding the area under the curve from 0 to 1, okay? Well, really what that is 0 to 1 of x cubed, which we can do very quickly. 1/4 x to the 4th from 0 to 1. So I get 1/4 of x to the 4th, 1 to the 4th, minus 1/4 of 0 to the 4th. So our answer ended up being 1/4. But I put you through a lot of misery. I made you guys do the long way, just like with derivatives. You had to do the long way first. So with integration, you got to do the long way, and then you learn the shortcut. And it's much, much faster with the shortcut. So this is a very exciting day. You got to learn the shortcut. All right.